Hello friends, welcome to my YouTube channel, Raja Gogasicoder 1719. Here we bring you amazing, unknown, and shocking information from around the world, knowing which you will definitely say, wow, could this be possible? So stay tuned until the end of the video, because today you are going to hear something you may have never heard before. Have you ever wondered what is the coldest place in the entire universe? We often think of space as cold, silent, and dark. But did you know there exists a nebula that is even colder than the empty vacuum of space itself? This mysterious object, called the Boomerang Nebula, is the coldest known place in the entire cosmos. In this video, we are going to take a deep journey into its mysteries, exploring its discovery, structure, strange physics, and what it tells us about the ultimate fate in the universe. Imagine a trip to the vast emptiness of space, where silence reigns and stars twinkle in the distance. Suddenly, your telescope captures something unusual, a strange and torus. First glance, a soft, ghostly cloud. But when scientists studied it closely, they realized they had discovered something extraordinary. The Boomerang Nebula. So what exactly is the Boomerang Nebula? In the simplest terms, it is what astronomers call a protoplanetary nebula. This doesn't mean planets are forming inside it. Instead, it is a transitional phase in the life of a dying star. When a star similar to our Sun reaches the end of its life, it begins shedding its outer layers of gas into space. This creates a glowing cloud that surrounds the central star, which is slowly fading away. Now, here's the part that makes the Boomerang Nebula stand out: its temperature. Scientists discovered that it is not just cold, it is the coldest natural place ever found in the entire universe. The Boomerang Nebula measures just 1 Kelvin above absolute zero. That's about minus 272 degrees Celsius, or minus 458 degrees Fahrenheit. To put that into perspective, it's even colder than the background temperature of the universe itself, which is about 2.7 Kelvin. This fact shocked astronomers. How could anything in the universe be colder than the universe itself? After all, the cosmic microwave background radiation fills all of space, and nothing should naturally dip below that level. And yet, this one nebula managed to defy expectations. The Boomerang Nebula got its name because of its shape. Through early ground-based telescopes, it appeared as if it had 2 curved lobes, resembling the wings of a boomerang. Later, more powerful telescopes revealed its symmetry more clearly, and it became equally famous as the Bow Tie Nebula. Imagine a giant cosmic ribbon floating across the galaxy, stretching out to a length of nearly 3 trillion kilometers. That's so vast that light itself would take several months to travel across it. But this nebula is not shining like the colorful pictures of space we often see. Instead, its light is very faint and hidden, requiring special telescopes that can detect infrared and sub-millimeter waves. Invisible light, it looks almost invisible, like a ghost lurking in the depths of space. So here we have a dying star, cloaked in clouds of gas and dust, cooling its surroundings to a temperature so extreme that no other place in the universe has matched it. The Boomerang Nebula is both hauntingly beautiful and scientifically puzzling. As we journey deeper into the story, we'll uncover how it was discovered, why it is so cold, and what secrets it holds about the future of stars, including our own sun. But before we answer those questions, let's go back in time and meet the astronomers who first stumbled upon this strange frozen wonder of the cosmos. To truly appreciate the Boomerang Nebula, we have to step back to the mid-1990s, a time when astronomers were busy exploring the hidden corners of our universe with increasingly powerful telescopes. In 1995, 2 astronomers, Keith Taylor and Mike Scarrett, were observing the southern skies in the constellation Centaurus. Through their instruments, they noticed something faint and unusual. At first, it didn't look like much, a dim, cloud-like object. But its unusual symmetry caught their attention. Unlike the irregular shapes of most interstellar clouds, this one appeared to have two lobes spreading outward, almost like wings. This strange object was cataloged and named the Boomerang Nebula because of its boomerang-shaped outline. Some even began calling it the Bow Tie Nebula, once clearer images showed its elegant, symmetrical structure. At that time, no one had any idea just how special this object was. To them, it was just another nebula. Beautiful, yes, but not extraordinary. That was about to change. As technology advanced, astronomers began using new tools to probe deeper into this mysterious cloud. Regular optical telescopes weren't enough because the nebula is cloaked in thick dust, which hides its central star and much of its light. To see through this cosmic curtain, scientists needed telescopes that could detect longer wavelengths of light, infrared and submillimeter. That's when the Boomerang Nebula revealed its shocking secret, using the Atacama Large Millimeter Submillimeter Array, ALMA, in Chile, one of the most advanced observatories on Earth. Astronomers made a groundbreaking measurement. They found that the gas and dust in the Boomerang Nebula were not just cold, but colder than the surrounding universe itself. At first, many scientists couldn't believe it. After all, how could anything in nature cool below the 2.7 Kelvin temperature of the cosmic microwave background radiation? That background is the afterglow of the Big Bang, a universal field of energy that fills all of space. It should, in theory, set the minimum temperature for everything. Yet here was this nebula, defying expectations, with a measured temperature of just 1 Kelvin, barely above absolute zero. The discovery stunned the astronomical community. The Boomerang Nebula instantly became famous as the coldest known place in the cosmos. Scientists now had an incredible puzzle in front of them. How could this happen? What kind of process could create such extreme cooling? The answer, as we will soon see, lies in the dying star at the heart of the nebula, and the way it is ejecting its outer layers at unimaginable speeds. But the story of its discovery doesn't end with the temperature. ALMA's high-resolution imaging also gave us a closer look at the nebula's breathtaking structure. Instead of a simple cloud, the Boomerang revealed itself as a vast, expanding outflow of gas, spreading across trillions of kilometers. Its perfect symmetry raised more questions. Was it shaped by magnetic fields? Or perhaps by a hidden companion star tugging at it with gravity? Even today, decades after its discovery, astronomers are still piecing together the answers. But one thing is certain: the Boomerang Nebula changed how we think about the extremes of the universe. It proved that space is not just vast and empty, but full of surprises, places where the laws of physics push the limits of what we once thought possible. And so, from a small discovery in 1995 to a global scientific revelation, the Boomerang Nebula went from being a faint speck in a telescope to one of the most extraordinary objects ever found in the cosmos. Now that we know how it was discovered, the next question is, why is it so cold? To answer that, we need to understand the science of temperature in space, and why the Boomerang Nebula is colder than the universe itself. Before we can understand why the Boomerang Nebula is so cold, we need to pause and talk about something fundamental. What does it actually mean to be cold in space? When we hear the word cold on Earth, we think of winter nights, ice, or the chill of snow on our skin. But in the cosmos, cold means something very different. Out there, temperature isn't measured by how the air feels, because there is no air. Instead, it's measured by the motion of particles, atoms, and molecules. The faster they move, the hotter they are. The slower they move, the colder they are. The ultimate limit is absolute zero, which scientists define as 0 Kelvin, or minus 273.15 degrees Celsius, or minus 459.67 degrees Fahrenheit. At this temperature, all atomic motion would completely stop. It's the coldest possible state in physics, a boundary that nothing can cross. Now here's the amazing part. The Boomerang Nebula is just 1 Kelvin above absolute zero. That means its gas and dust are moving so slowly that they are barely alive with energy at all. To really appreciate this, let's compare it with other cold places in the universe. The cosmic microwave background radiation, the afterglow of the Big Bang that fills all of space, is about 2.7 Kelvin. This is considered the natural baseline temperature of the universe. A dark molecular cloud, where new stars are born, usually measures around 10 to 20 Kelvin. Liquid nitrogen on Earth, which can freeze almost anything, is 77 Kelvin. Even Pluto, the distant ice world on the edge of our solar system, is a relatively warm 40 Kelvin compared to the Boomerang. So when we say that the Boomerang Nebula is at 1 Kelvin, we are talking about a place colder than the background of the universe itself, colder than anywhere else scientists have ever measured in nature. But how is that possible? Shouldn't everything in the universe be stuck at 2.7 Kelvin because of the cosmic microwave background? The answer lies in the physics of expansion. Here on Earth, you probably experienced a similar phenomenon without even realizing it. When you spray a can of compressed air, the nozzle feels icy cold. That's because when gas expands rapidly, it cools, the energy spreads out, and the temperature drops. This process is called adiabatic cooling. The Boomerang Nebula is a cosmic scale version of this everyday effect. At its center is a dying star that is ejecting gas at extraordinary speeds, hundreds of thousands of kilometers per hour. As this gas shoots outward into space, it expands so quickly that it cools below the background temperature of the universe. It's almost like the nebula is creating its own natural deep freezer in space, one so efficient that it beats the cold of the cosmos itself. This discovery not only shocked astronomers, but also opened new questions. If a dying star can create such extreme cold, are there other nebulae out there doing the same? Or is the Boomerang truly unique? We'll return to that mystery later. But first, let's look more closely at the Boomerang's unusual structure, its ghostly boomerang-like shape, and what it reveals about the final breath of the star at its heart. By now, we know that the Boomerang Nebula is the coldest natural place in the universe. Colder than the cosmic microwave background, colder than Pluto, colder even than liquid helium used in scientific labs. But the real mystery is why. What makes this one nebula so unique? The answer lies in the strange final chapter of its central star's life. At the heart of the Boomerang Nebula is a dying star, one not so different from our own sun. Billions of years ago, it burned brightly, fusing hydrogen into helium, shining steadily in the constellation of Centaurus. But now, as it nears the end of its life, it has become unstable. The star is shedding its outer layers in a dramatic, almost violent outburst. Imagine the star as a giant furnace that has begun to crack. Instead of burning calmly, it's throwing its outer gases into space at astonishing speeds, nearly 600,000 kilometers per hour. This outflow of gas is what creates the nebula we see today. But here's the fascinating part. When gas expands so rapidly, it undergoes what scientists call adiabatic cooling. It's the same principle as when you spray a can of compressed air and the nozzle feels icy cold. On Earth, that cooling lasts only a few seconds. But in the Boomerang Nebula, it happens on a mind-boggling scale. The star's expelled gas spreads out into the emptiness of space so quickly that it cools to 1 Kelvin, a temperature lower than the background radiation of the universe itself. In other words, the nebula has built a giant cosmic refrigerator powered by nothing more than the death throes of its star. Now, you might wonder, why don't all dying stars produce such cold nebulae? After all, many stars go through this phase of losing their outer layers. The difference is speed. Most stars expel their material more slowly, giving the gas time to heat up under the influence of radiation. But in the Boomerang Nebula, the gas is moving outward so quickly and so efficiently that it doesn't have time to warm up. Instead, it cools down below anything we thought possible in the natural universe. Another clue lies in the shape of the nebula itself. Its twin lobes, those giant wings of gas stretching across trillions of kilometers, suggest that the star may not be alone. Some scientists believe a hidden companion star could be influencing the outflow, focusing the gas into two powerful jets, rather than letting it expand evenly in all directions. This focused expansion might be one reason for the extreme cooling. Think of it like a fire hose spraying water. When the pressure is high, the spray is powerful and spreads rapidly. The Boomerang's central star is doing something similar, but instead of water, it's spraying frozen streams of gas into space. What makes all this even more incredible is the scale. The Boomerang Nebula spans nearly 3 trillion kilometers across, yet much of it is colder than anything we can produce even in our most advanced laboratories. This combination of rapid expansion, unique structure, and possible stellar companionship makes the Boomerang Nebula a one-of-a-kind phenomenon, a perfect storm of conditions that has created the coldest known place in the universe. But beyond the science, there's also something poetic here. This nebula, colder than the void, was born from the fiery life of a star. The heat and energy that once lit up its solar system are now gone, replaced by a vast, frozen cloud that silently drifts through the galaxy. And this brings us to our next question. What does the Boomerang Nebula actually look like? What gives it its haunting bow tie shape? And what can its structure tell us about the fate of its dying star? Let's explore that next. As we drift closer to the Boomerang Nebula with our mind's eye, we notice something fascinating. Unlike many other nebulas, which often appear as chaotic clouds of gas, the Boomerang has a peculiar and haunting symmetry. It looks like a ghostly bow tie stretched across the darkness, or like the outstretched wings of a giant cosmic butterfly. This unique shape is what gave the nebula its name. When astronomers first observed it, the curved edges looked like a boomerang, frozen in mid-flight. Later, sharper images revealed an even clearer structure. 2 vast lobes of gas streaming out from the central star in opposite directions. This gave rise to its second nickname, the Bow Tie Nebula. So why does it look this way? The answer lies in how the dying star at its center ejects material. Most stars in their final stages puff out gas in all directions, forming roughly spherical nebulae. But in the case of the Boomerang, the gas has been funneled into 2 massive outflows, stretching outward like twin jets. Some scientists suspect the star may have a hidden companion star, orbiting closely and shaping the flow of material through gravity. Others believe that magnetic fields or a rotating stellar disk could be responsible for channeling the gas into 2 opposing streams. Whatever the cause, the result is one of the most striking and symmetrical shapes in the universe. Now let's talk about the scale. Each of these lobes extends trillions of kilometers into space. In fact, the entire nebula spans almost 3 trillion kilometers across. To put that into perspective, if you place the Boomerang Nebula at the center of our solar system, its wings would stretch far beyond the orbit of Pluto. The sheer size of this structure is almost beyond imagination. What makes it even more extraordinary is its faint glow. Unlike the dazzling colors we see in famous nebulae like the Ring Nebula or the Cat's Eye Nebula, the Boomerang appears ghostly pale. This is because its central star is hidden within thick layers of dust and gas, blocking most of the visible light. Instead, the nebula shines faintly in scattered starlight and in the infrared spectrum, invisible to our eyes but detectable by specialized telescopes. Through powerful observatories like the Hubble Space Telescope and ALMA, we can now glimpse the fine details of its structure. The lobes aren't perfectly smooth. They are filled with clumps, filaments, and ripples of gas, evidence of the turbulent forces that shape them. These intricate patterns tell scientists about the speed and direction of the gas flows, helping them piece together the star's final moments. Interestingly, the bow tie shape is not permanent. In just a few thousand years, a blink of an eye in cosmic terms, the nebula structure will change. As the central star continues to evolve, the lobes will expand and thin out. The once sharp bow tie will blur, transforming into a more rounded planetary nebula. Eventually, all that will remain at the center is a faint white dwarf star, glowing weakly amidst the fading gas. For now, though, the Boomerang Nebula remains one of the most beautiful and mysterious structures in the night sky. Its shape is not just a visual wonder, it is a clue, a fingerprint of the forces that sculpted it, and a reminder that even in death, stars can create astonishing works of cosmic art. But there is another layer to this story. Behind that haunting shape lies the deeper tale of the central star itself, its struggles, its collapse, and its transformation into something entirely new. To understand the full picture, we need to step inside the heart of the nebula and explore the dying star at its core. At the heart of every nebula lies a story, and the Boomerang Nebula is no different. Hidden behind its vast, frozen wings of gas and dust is a star in its final moments of life. Billions of years ago, this star was much like our own sun, shining steadily, fusing hydrogen into helium, and bringing light and warmth to whatever worlds may have once orbited it. For most of its life, it lived in balance, its gravity pulling inward, while nuclear fusion pushed outward. But nothing in the universe lasts forever. As the star grew old, it began to run out of fuel. With less hydrogen to burn, its core shrank under gravity while its outer layers expanded, turning it into a red giant. This is the same fate that awaits our sun about 5 billion years from now. When that happens, the sun will swell to engulf Mercury, Venus, and possibly even Earth. For the Boomerang central star, this process has already begun, and it's far more violent than scientists first expected. Instead of simply swelling and gently releasing gas, the star erupted, blasting away its outer layers at incredible speeds. These ejected shells of gas and dust are what we now see as the bow tie-shaped nebula. But the star is not dead yet. Deep inside, its core is still burning, still contracting, still transforming. Over time, it will shed more material until all that remains is a tiny, dense core known as a white dwarf. A white dwarf is one of the strangest objects in the universe. It's only about the size of Earth, yet it contains nearly the same mass as the original star. That means a teaspoon of its material would weigh tons here on Earth. This fate awaits the star at the center of the Boomerang Nebula, and one day, our own sun too. Right now, however, the star is in its protoplanetary nebula phase, a short transitional period that lasts just a few thousand years. In cosmic terms, that's incredibly brief. The nebula we see today is like a snapshot, capturing a rare moment in a star's death. Soon, the Boomerang will evolve into a fully developed planetary nebula, glowing more brightly as the central star heats up and illuminates the surrounding gas. The Boomerang story reminds us of the cycle of stellar life and death. Stars are born from clouds of gas. They shine for billions of years, and eventually they give their material back to the cosmos. That material, hydrogen, helium, carbon, oxygen, becomes the building blocks for the next generation of stars and planets. In fact, the very atoms that make up your body were once inside stars that lived and died long before our sun was born. There's something profoundly poetic about this. A star's death may seem like an ending, but in truth, it is a new beginning. The Boomerang Nebula, cold and ghostly as it is seeding the galaxy with the raw materials for future worlds, perhaps even future life. So when we look at this dying star, we are also looking at the distant fate of our own sun. Billions of years from now, long after humanity is gone or transformed, our sun will expand, shed its outer layers, and leave behind its own nebula. Somewhere in the galaxy, another civilization may look at it and wonder about the star that once burned in this part of space. The Boomerang Nebula's central star is more than just a fading light. It is a cosmic storyteller, whispering to us about the past, the present, and the destiny of stars. And yet, while its star tells us about death and rebirth, the nebula itself invites us to compare it with other wonders of the universe. How does the Boomerang measure up against other famous nebulae? That's what we'll explore next. When we look across the night sky, we find many kinds of nebulae, each with its own beauty, its own story, and its own secrets. But how does the Boomerang Nebula compare to its cosmic cousins? Let's begin with some of the most famous examples. Take the Ring Nebula in the constellation Lyra. Through a telescope, it appears as a glowing smoke ring, about 2,000 light-years away from Earth. The Ring Nebula was once a star like our sun, and today it shines brightly in colors of green, red, and blue, lit up by ultraviolet radiation from its central white dwarf. It is stunningly beautiful, but its temperature, at around 10,000 Kelvin in the glowing gas, is far hotter than the Boomerang. Then there is the Cat's Eye Nebula, located about 3,000 light-years away in Draco. It is one of the most complex and detailed planetary nebulae ever observed. The Cat's Eye has swirling concentric shells, knots, and filaments, almost like the delicate patterns of stained glass. It's vibrant and intricate, but again, its temperatures are nowhere near the icy extremes of the Boomerang. The Helix Nebula, sometimes called the Eye of God, is another famous example. Found in the constellation Aquarius, it is one of the closest planetary nebulae to Earth. Photographs from the Hubble Space Telescope reveal a glowing blue-green core surrounded by reddish gas, stretching across nearly 2.5 light-years. It's a popular target for amateur astronomers because of its brightness and clarity. Now compare these to the Boomerang Nebula. Unlike the Ring, the Cat's Eye, or the Helix, the Boomerang doesn't dazzle us with brilliant colors and visible light. Instead, it hides its beauty behind thick veils of dust. To the naked eye through optical telescopes, it appears faint and ghostly, almost invisible. Its real secrets are revealed only in the infrared and submillimeter wavelengths, where we can measure its extreme cold. In terms of structure, the Boomerang is also different. The Ring Nebula and Helix Nebula are roughly circular, while the Cat's Eye is highly complex with multiple layers. The Boomerang, however, is sharply symmetrical, with two lobes stretching outward like a bow tie. This shape is a direct result of its unusual high-speed gas ejections. And then there's the temperature. This is where the Boomerang stands completely alone. While other nebulae glow warmly with energy from their dying stars, the Boomerang is so cold that it surpasses even the natural background temperature of the universe. At just 1 Kelvin, it is colder than any nebula, colder than any dark cloud, colder than the cosmic microwave background itself. No other known nebula even comes close. So while the Ring, Cat's Eye, and Helix amaze us with their colors and artistry, the Boomerang amazes us with its physics. It may not be the brightest or most beautiful invisible light, but it is the most extreme, the coldest known object in existence. This contrast teaches us an important lesson. Beauty in the cosmos is not only about what we see, but also about what we discover. Sometimes the faintest, most hidden objects hold the most extraordinary stories. The Boomerang Nebula may look like a pale ghost compared to its colorful cousins, but its mystery, the mystery of how a dying star created the coldest place in the universe, makes it one of the most extraordinary nebulae ever found. And beyond comparisons, the Boomerang also serves as a cosmic laboratory. It gives scientists a chance to study extreme physics, to understand the last breaths of stars, and to explore conditions that we cannot recreate on Earth. In the next chapter, we'll dive into what the Boomerang Nebula actually teaches us about the universe itself. The Boomerang Nebula is more than just a record holder for coldness. It is a window into the grand cycle of life and death in the universe. By studying this strange, frozen cloud, astronomers are learning valuable lessons about how stars live, how they die, and how they shape the galaxies around them. First, the Boomerang shows us what happens when stars like our Sun near the end of their journey. The central star of the nebula is not a massive supernova candidate. Instead, it's a sun-like star quietly shedding its outer layers. This process, though gentle compared to a supernova, is incredibly important. It tells us what our own sun will eventually go through billions of years from now. The second lesson lies in stellar winds. The Boomerang's extremely fast outflow of gas, more than 160 kilometers per second, is what made it so cold. By pushing gas into space so quickly, the star created a natural refrigeration system, cooling the expelled material below the temperature of the cosmic microwave background. This helps scientists understand how stars transfer matter and energy into their surroundings. Third, the Boomerang Nebula reveals the role of binary star systems. Many astronomers believe the dying star at the center has a companion, possibly a smaller star or even a white dwarf. This partner may be responsible for shaping the bow tie structure and driving the intense outflow. If true, it shows us that stars often do not live or die alone. Their interactions can sculpt the universe in dramatic ways. Another lesson is about cosmic recycling. The gas and dust in the Boomerang will not remain there forever. Over time, this material will drift into space and become part of the interstellar medium. From that medium, new stars and planets may one day form. In this way, the death of one star provides the raw ingredients for the birth of another. The Boomerang is a reminder that the universe is constantly renewing itself. But perhaps the most profound lesson is this. The Boomerang Nebula proves that the cosmos is full of surprises. When astronomers first discovered it, no one expected to find a natural object colder than the background temperature of the universe. It forced scientists to rethink what is possible. The universe, it seems, is always ready to challenge our assumptions and show us something new. On a symbolic level, the Boomerang Nebula also teaches us humility. Here is a star, thousands of light years away, quietly dying in the coldest place in existence. Unseen by the naked eye, unnoticed for billions of years. And yet, when we discovered it, it deepened our understanding of physics, of cosmic evolution, and even of our own future. So the Boomerang Nebula is not just a curiosity, it is a cosmic teacher. It whispers to us about the fragility of stars, the inevitability of change, and the endless creativity of the universe. It reminds us that even in the coldest, darkest corners of space, there are lessons waiting to be learned. In the next chapter, we'll look beyond science and explore the cultural and philosophical reflections inspired by the Boomerang Nebula. Because sometimes the greatest meaning comes not from equations and data, but from the wonder we feel when we gaze at the universe. When we study the Boomerang Nebula scientifically, we uncover fascinating facts about temperature, gas flows, and dying stars. But beyond the equations, there is a deeper layer, a cultural and philosophical reflection about what this frozen cloud means for us as human beings. For centuries, people have looked at the night sky not just with curiosity, but with reverence. The stars have been as symbols of gods, guides for travelers, and reminders of eternity. Today, even with powerful telescopes and advanced physics, that sense of wonder has not disappeared. In fact, discoveries like the Boomerang Nebula remind us that the universe is not only vast, it is also mysterious and poetic. Think about the name itself, Boomerang Nebula. A boomerang is something that leaves but eventually returns. Perhaps this is symbolic. The star inside the nebula is casting out its final breath, sending gas and dust into space. But someday those same materials will return in a new form, as part of a new star, a new planet, or even the building blocks of life. It is a cosmic reminder of cycles, of endings that lead to beginnings. In many cultures, coldness is associated with silence, stillness, and even death. The Boomerang Nebula, being the coldest place in the universe, can be seen as a metaphor for the final stage of existence. And yet, even in this extreme cold, there is beauty. Its bow tie shape and perfect symmetry remind us that endings can also be elegant. From a philosophical perspective, the Boomerang Nebula forces us to confront our own impermanence. Our sun, too, will one day reach its end. Billions of years from now, Earth will no longer be habitable, and our star will cast off its layers, just as the Boomerang star has. The nebula is not just a distant phenomenon, it is a preview of our own cosmic destiny. Yet there is also comfort in this realization. If the death of one star can seed the birth of another, then perhaps the universe itself is never truly ending. It is always transforming. The Boomerang teaches us that death is not final, but part of a grand cycle of renewal. Artists and poets might see it differently. They might imagine the nebula as the ultimate frozen breath of a star, a whisper carried across light years, preserved in cosmic silence. Spiritual thinkers might interpret it as a reminder that the universe holds mysteries beyond human understanding, mysteries that inspire awe, humility, and reflection. Even for ordinary people looking at the pictures, the Boomerang Nebula can awaken a sense of wonder. It is humbling to know that somewhere, thousands of light years away, a star is quietly fading, and in its fading it becomes the coldest, most silent place in all of existence. Ultimately, the cultural and philosophical meaning of the Boomerang Nebula is this. It is both an ending and a beginning, both a mystery and a revelation. It tells us that science and spirituality do not have to be opposites. They can work together to remind us of our place in the cosmos. As we move into our final chapter, let us take all these lessons, scientific and philosophical, and reflect on the lasting legacy of the Boomerang Nebula. What does this frozen marvel mean for humanity's future understanding of the universe? As our journey through the Boomerang Nebula comes to an end, we are left with more than just scientific facts. We are left with a story about life, death, and renewal on a cosmic scale. The Boomerang Nebula began as an ordinary star, much like our own sun. Over billions of years it burned its fuel, shining steadily in its corner of the galaxy. But like all stars, it could not burn forever. When the end came, it released its final breath, casting vast amounts of gas into space at incredible speed. That breath, that release, created the coldest place in the universe, an astonishing laboratory frozen at just 1 degree above absolute zero. This nebula is now a cosmic record holder, not because of its brightness, not because of its colors, but because of its extremes. It shows us what nature is capable of, what strange and unexpected outcomes can arise from simple physical laws. It is a reminder that even in the universe we think we know, there are surprises waiting to be found. For astronomers, the Boomerang Nebula is a key to understanding stellar evolution. It offers clues about how stars shed their outer layers, how binary companions may shape their fate, and how matter is recycled into the galaxy to form new generations of stars and planets. In studying Boomerang, we are also studying the future of our own sun, and perhaps the fate of our own solar system. But beyond science, its legacy is deeper. The Boomerang Nebula reminds us of our smallness, but also of our connection to the cosmos. We are made of stardust, forged in the depths of ancient stars. Just as the boomerang's gas will someday form something new, the atoms inside our bodies once came from long-dead stars billions of years ago. In a very real sense, we carry the history of nebulae within us. And what about the cold? The boomerang shows us that even in the coldest, most silent place imaginable, there is still motion, still energy, still transformation. Life may not exist there, but the seeds of life, the elements, the chemistry, are preserved within it. Out of silence, new songs of creation will someday emerge. The legacy of the Boomerang Nebula, then, is not just scientific, it is human. It inspires wonder, humility, and imagination. It tells us that the universe is far stranger, more beautiful, and more mysterious than we can ever fully comprehend. And that is perhaps the greatest gift of all. So the next time you look up at the night sky, remember that somewhere out there, 5,000 light years away, a dying star has created a frozen masterpiece, the coldest place in the known universe. It is waiting quietly for us to continue its story. This is the Boomerang Nebula, a symbol of endings, beginnings, and the eternal mystery of the cosmos. So friends, this was today's amazing information. Hope you liked this video and learned something new. If you found the video interesting, don't forget to like, share, and subscribe. See you again in the next video with another new and surprising thing. Until then, stay happy, stay healthy, and stay tuned to learn. Jai Goga Sikodermeye.